Module 19. Analyzing data with automated tools. In Module 19, we'll be using the Analysis Toolpack, using GoalSeek, using a data table, using the solver, some exercises and their solutions, and a final summary. So why use automated tools? Well, automated analysis tools are best used to gain complex engineering, mathematical or statistical data from a spreadsheet or data range. Using the tools can provide convenient macros that save time by performing higher function calculations by just including or changing the input data. And some of the tools can even create charts. So let's get started. Before we begin using the automated tools, we first need to discover whether or not they're installed onto Excel. The toolpack is what's known as an add-in. An add-in is a program that's added on to the software that performs extra functions. The easiest way to find out whether or not the toolpack is installed on Excel is by going up to the Quick Access toolbar, going to More Commands, and selecting Add-ins from the menu on the left. In this version, we can see that the Analysis Toolpack, its Visual Basic version, as well as a few other add-ins, are currently installed into Excel. Once these are installed, we don't need to uninstall them at any time in the future, but we can always disable and enable them as we need them. If the Analysis Toolpack is currently not installed on your version of Excel, selecting it from the list of add-ins that appears in this menu will install it into Excel and allow it to be used. If we go to the Data tab in the ribbon, the toolpack will add two further options here on the right hand side. Currently they're disabled, but if we go to the Developer tab and go to the Add-ins button, the currently installed add-ins on Excel are available here in this list. They're currently disabled as the checkboxes are all empty. If we check our boxes and click OK, Excel will re-enable their use, and we can find them once again if we go to the Data tab, and Data Analysis and Solver are now available. Once the toolpack has been installed, you'll find it in the Data tab and on the right under Data Analysis. The Data Analysis window will open and contains a full list of the analysis tools. Many of these tools are used for high-level mathematics, engineering, and statistics, so in all likelihood it will be unlikely that you'll use many of these. The two that may be used and you'll find useful are the random number generation and the rank percentile, and we'll show how these two work now. Excel has a function called randBetween, which will generate a random number between two given values. So if we insert this function within cell A1, the randBetween function works by equals name of the function, randBetween, and then two parameters, the lowest number and the highest number, so 1 and 6, exactly the same as the face of a dice. So if we click return, Excel will return the random number between 1 and 6. We can always copy this and paste it beneath to get a selection of random numbers. But what if we want to generate random numbers that aren't whole numbers or whole integers, and we need decimal values? This is where the Data Analysis tool can come in handy. If we need to generate a collection or range of random decimalized numbers, we can go to the Data tab in the ribbon, go to Data Analysis, and choose Random Number Generation from the list. Click OK, and the window opens with its first option, the number of variables. The number of variables is the same way of saying how many columns we wish our random numbers to be generated across. So for this example, we'll say 3. and the number of random numbers is how many random numbers per column. So we'll say 3 for this as well. Once we're happy, we can change the distribution by using one of the mathematical archetypes, but we'll keep it with uniform. And then we can change the parameters. As we want numbers between 1 and 6, we'll keep it to 1 and 6. And we can also change the output options. We can push our range to the one that's already been decided in Excel, or we can put a new worksheet or a new workbook. Once we're happy, we click OK. And our random decimalized numbers are generated across 3 columns containing 3 sets of random numbers in each column. For the rank percentile demonstration, we've reopened the AutumnGate Dairy spreadsheet. I've used the group tool to hide everything other than the product, total sales, wastage and wastage cost. To use the rank percentile, we go to the Data tab in the ribbon, go to Data Analysis and choose Rank Percentile and click OK. We next need to select our input range, which is the total sales, wastage and wastage cost, and select the values beneath it. Next, we need to make sure that our data is grouped by columns and that we should check that the labels are in the first row. If we have no labels in the first row, we leave this empty. Finally, we select an output range, again either within the same spreadsheet, on a new sheet, or in an entirely new workbook. And we'll put ours just here. Once we're ready, click OK. The rank and percentile data for our total sales, wastage and wastage cost is included on our spreadsheet. Within the data analysis window, there's a wide variety of different analysis tools available. Unfortunately, some of which are so complicated it would take a module in their own right just to explain 1 or 2 of them. No matter what type of data you're trying to analyze, there will be a macro or function available in this window for you to use. GoalSeek is a function that allows us to play with different values to get the answer we're looking for. Here we have the simplest sum there is, 2 plus 2 equals 4. But imagine we want the value in cell A3 to be 5. Well, if we go to the Data tab, go to the What If analysis and open up the GoalSeek option, the GoalSeek window opens with its 3 parameters. We'd like to change the value in cell A3 to 5, so we set the cell to A3. Next, the value we'd like to see is 5, so we add that to the window. And lastly, it asks us which cell needs to change to get this value, so we'll choose cell A1. Once we're happy, click OK. And GoalSeek has discovered that by changing the value in cell A1 to 3, adding it to cell A2 gives us the result of 5. If we're happy with this, if we click OK, this change becomes permanent. If we're not happy, we can click Cancel. While this might seem simplistic, it's very useful in things like working out loan repayments using the per month function. So here we have a simple student loan repayment, and this uses the per month function, which I've highlighted just down here. The per month function works like all functions. It starts with an equals, then the function name. So equals PMT, then the start of our argument. 7% for the interest rate divided by 12 months, the total amount of payments, and minus the principal. Gives us a total monthly repayment of €99.01. I've used the per month function here in cell B6, but this one uses the cell references. This one's only here to show how the per month function performs and gives you the values to show how they're used. So let's imagine with our student loan we wish to make our payments 80 a month rather than 99. This is where GoalSeek can really help. Again, we go to the Data tab in the ribbon, the What If analysis, and go to GoalSeek. This time the set cell is cell B6, and we want to change its value to 80. The last parameter asks us to get this value to 80, we need to change one of these three cells. We can either change the interest rate, the number of payments, or the principal. So let's see what happens if we change the interest rate. The GoalSeek returns and tells us we can get this down to 80 a month if the interest rate was at -2, which is unfeasible. So we'll cancel this GoalSeek and try a new one. Again, we want the value to be 80, and this time we're going to change the number of payments. So we'll change the cell B4 and click OK. This time the GoalSeek has informed us our payments will be down to 80 a month if we extend the length of the contract by at least 18 months. So there's one solution. We can also try one last one by changing the principal. Again, the What If analysis, GoalSeek, a value of 80, by changing the cell B5, which is our principal, and click OK. A monthly repayment of 80 a month over 60 months at 7% interest means we can only borrow 4,040 euros. So you can see the use of how GoalSeek can help. Once we're happy with any of the GoalSeek statuses, we can click OK, and this now becomes permanently changed within our spreadsheet. We saw with GoalSeek how to get a desired answer by changing just one variable. But what if we want to see all the variables and all the results? Well, a data table can help us do that. Right now we're back with our student loan spreadsheet, and we have an interest rate of 3%, which, when plugged into our per month function, gives us our monthly repayments. But what if we want to see what the monthly repayments would be if we had a table with a range from 3 to 10%? Well, we can create a data table that can show us just that. First of all, we need to define the formula we're going to use within the data table, which is here in cell C7, the per month function. So we can go up to F2, type in equals C7, and our function is pasted here. Next we need to put in our variables, which is our interest rates, and we'll put them down the side here. And there we have our interest rates and our function. Next, we need to define the area that's going to be our data table. Then we go to the Data tab, go to the What If analysis again, and choose Data Table, which is the bottom option. The Data Table window opens, and it only has two parameters, a row input cell and a column input cell. We only need to add one value to this window. If our data was being arranged horizontally, then we'd put in a row input cell. As our data is being arranged vertically, it's just the column input cell. And the column input cell is our first variable, 3%. Now, when making data tables, it's always best to start the data table with the reference. So while it's 3% here, we should also start with 3% here. If we start higher or lower, we'll get an inaccurate result. So once we're happy with our cell input, we click OK. And our results are pasted below. We may need to change this now to currency data to make things a little more easy to see. And there we have it. from 3 to 10%. This is the range of our monthly repayments based on the data table, the variables we've plugged into it, and the function that it's using. One last word on data tables. The results that are pasted within our data table, not our variable or our function, but the results here, are all defined as a table with a cell reference. The cell reference in this case is the variable, so cell C4, which was our interest rate. Just remember, we can't use these results in other functions. We have to convert them to a value, and we can do that just simply by copying them and then repasting them as values. And if we click on one, we now see we have the value rather than the cell reference and table. The solver is perhaps the most powerful tool within the Toolpak add-in, but it can be complicated to use, so we'll go through the process step by step. We're going to use the solver with this sales and delivery spreadsheet. The spreadsheet is spread into 4 main areas: the sales trips, the hypothetical trips, the cost, and the constraints. The sales trip area is just for information. It tells us the 4 regions we can visit, how many miles away they are, the deliveries we can make, the stops we must make, the sales points we can visit, and the cost of the trip. Beneath this is the hypothetical trip, or the decision variable. In other words, we can add values to these to tell us how many trips we're going to make to the region. For example, if we add 1 trip to Newmarsh and 1 trip to Beech Grove, the cost of the trip is calculated in this total cell B17. The trips added to the hypothetical trip range here are also included here and calculated here. They're also calculated in the totals column of our constraints. So it tells us that a trip to Newmarsh and Beech Grove totals 36 miles, adds to 5 deliveries, 3 stops, 4 sales points, and costs us €165. If we add another trip to Sunnybrook, again our totals are recalculated, but our total cell in B17 is now outside the range because the trips themselves can't cost any more than €175. If it's below €175, it remains green, like so. The last part of our spreadsheet is the objective. In this case, we need to find a route that ensures at least 2 deliveries, no more than 3 stops, at least 2 sales, covers no more than 45 miles, and can cost no more than €175. We're going to use a solver to achieve this. So we need to open the solver window, and that can be found in the Data tab up on the ribbon, and here on the right. Remember, the Toolpak add-in has to be enabled for us to use this. If we click Solver, the Solver Parameters window opens, and while it looks complicated, we'll take it step by step. The first step is to set the objective. In this case it's cell B17, or the total, and we need B17 to contain a value of €175. Now, to achieve this value, in this cell, we need to change the value of other cells. So in this section, by changing variable cells, it's really asking us what cells we can change. And the cells we can change is the range B11 to E11. So if we click Solve, the solver has found a solution. But unfortunately, it's not practical. It's found to get an exact value of €175, we need to take 1.03 trips to Newmarsh, 0.03 trips to Greenfield, and so on. The problem is we need these values to be whole numbers or integers. So we're going to restore the original values, and by keeping this box checked, when we click OK, we return to our solver parameter window. So to achieve our goals here, we need to add some rules or constraints. So if we click Add, the first constraint we can add is to make sure that our cell reference, in this case cells B11 to E11, are always int or integers. And we click OK. So now we have all our original references and this new rule here, or constraint. Everything that will be added to the cells B11 to E11 will always be whole numbers. So if we click solve again, the solver tells us it could not find a feasible solution. The reason being is that no matter what whole numbers are added here, there is no calculation that will give us exactly 175 euros. So once again, we need to return to our parameter dialog. So setting the value to exactly 175 was a mistake. We need to set it to a minimum. And we also need to add some new rules. If we calculate now with the minimum amount and press solve, the solver has found a solution, but the solution is to achieve the minimum amount in the total cell means taking no trips whatsoever. So once again, we return to our solver parameter and we're going to add some rules. And this is where our constraints table comes into play. In our required column are the values required to achieve our objective. So we'll add a new rule that states that whatever appears in cell L11 can only be less than or equal to 45 miles. And that's currently here, less than or equal to, and then our required amount. So now we'll add the second rule, that whatever appears in L12 has to be greater than or equal to 2. We'll add our third rule, which states that anything in column L13 has to be less than or equal to 3. Less than or equal to 3. Our fourth rule has to be greater than or equal to 2. And our final rule, anything held in L15 has to be less than or equal to 175. So there's our parameter window once more. This time we have our objective cell, which is B17, with the minimum possible value held within it by changing these cells and following these rules. So if we now click solve, the solver has come up with the last solution. The solution is to achieve less than 45 miles, have 2 or more deliveries, have 3 or less stops, and have 2 or greater sale points with a cost under 175. There's only one trip that can be possibly made, and that's to Sunnybrook, which follows all the rules we've set within our solver. For the first exercise, generate a data table that uses the monthly payment formula but gives us a variable for the number of payments. Okay, so to create our data table, we first need to generate our formula. In this case, it's the PMT formula. Then we add in our rates and constants. Close our argument. And now we need to recreate our number of payments. Remember, we need to start with the same setting as has been applied here. So we start with 24. and we'll generate it up to 5 years. Next, we select our table, go to the Data tab, and go to the What If analysis and Data table. Our column input cell is C5, the number of payments, and we click OK. And here are our monthly payments for 2 years, 3 years, 4 years, and 5 years. For the next exercise, fulfill the objectives in the box by using the solver. So we need to find a route that ensures at least 3 deliveries, no more than 3 stops, at least 4 sales, covers no more than 45 miles, and can cost no more than €250. Okay, so we first need to start by going to the Data tab and selecting Solver. Our objective again is cell B17. We know we want a minimum value, so we need the least number of trips, and we need to change the variable cells, which is the range B11 to E11. We next need to add our constraints. The first constraint being that the range B11 to E11 can only contain int or integers. Next, we need to add the next constraints, which are all here in the required section and also in the objective. So the first constraint will be that the total amount of miles has to be less than 45. The next rule is that the amount of deliveries must be greater than or equal to 3. The third rule is that the stops must be less than or equal to 3. The fourth rule, that there must be 4 or more sales and the final rule, that the trips can cost no more than €250. So there's our objectives, our values, and our set of rules. We'll click Solve. The solver has returned a solution that involves 2 trips, a trip to Green and a trip to Beech Grove. We can see that everything's within the guidelines. We're under €250. The total miles are 18. We have 4 deliveries, which is greater than 3. We have 2 stops, which is less than 3. And we have 5 sales, which is greater than 4. And finally, our costs are below 250. So in summary, using the automated tools can really save time when defining or developing statistical analysis for given data ranges. While not every tool available is appropriate for analysis, most are useful for searching through the fine detail. And finally, experimenting with different results can often help find the optimal solution to a problem. Thanks very much, and we'll see you in the next module.